In this video, we are going to talk about circular orbits. A circular orbit is when an object follows a circular path around another object. We know many examples of this. You can think about moons orbiting around planets, planets orbiting around the sun, and satellites orbiting around the Earth. But what's holding these objects in their orbit? Like, why don't they just drift away? Well, the answer is centripetal force. The net force acting on an object that's in a circular orbit is the centripetal force. And now remember, we learned that we can describe the centripetal force using this equation, where F net is equal to mv squared divided by r. M is the mass of the orbiting object in kilograms. V is the speed of the orbiting object in meters per second. And r is the radius of the orbit. And I want to make it clear that the radius of the orbit is measured from the center of the planet. So it is equal to the radius of the planet plus the additional height from the orbiting object. And now that's the equation for centripetal force. But I want to figure out what is causing this net force. So let's draw a free body diagram. When I draw a free body diagram for the orbiting object, we can see that the only force acting on it is the force of gravity. And that means the net force is equal to the force of gravity. And so in our centripetal force equation, we can replace F net with the force of gravity. And so now we can see that it's the force of gravity that's providing the centripetal force and keeping the orbiting object in its circular orbit. And now I hope you remember that for an object undergoing circular motion, v is equal to 2 pi r divided by t. So you can make this substitution if you are asked to find the period of the orbiting object. And now one last point. We are used to replacing the force of gravity with mg, where g is the acceleration due to gravity and it is equal to 9.8 meters per second squared. But that value of g is only valid when the object is on the surface of Earth. So for an object that's orbiting around the planet, we cannot use the same value of g. We have to use the acceleration due to gravity for the orbiting object. So if you need to replace the force of gravity with mg, remember that g is the acceleration due to gravity for the orbiting object. And if you ever needed to calculate this value for g, you can use this equation. Now let's do a quick example. In this question, we have a moon which is orbiting a planet. We are told that the moon has a mass of 9 times 10 to the 22 kilograms. The radius of the orbit is 2 times 10 to the 8 meters. And the force of gravity is 1 times 10 to the 19 newtons. And we want to know what is the moon's orbital period in days. Now remember, the centripetal force is what's keeping this moon in its orbit, and the centripetal force has the equation F net is equal to mv squared divided by r, and we know the net force acting on this moon is the force of gravity, so we can replace F net with the force of gravity. And then we have to remember that v is equal to 2 pi r divided by t, and t is the period, which is what we want to solve for. So we will replace v with 2 pi r over t, and then all we need to do is simplify this equation, and then we need to rearrange and isolate for t, because that's the period of this moon's orbit. Once we've isolated for the period, we can plug in our values for the moon's mass, the radius of the orbit, and the force of gravity. And what we find is that the period of this orbit is 8,429,778 seconds. And now we were asked to give the answer in days. So we need to do a quick unit conversion and convert this from seconds to days. And after I'm done this unit conversion, we find that the period is about 97 days. And that's how you answer questions about orbiting objects.